Well, hi, and welcome to my shop. See, I'm not the only one who works hard in this shop. Shadow works hard in here too. Shadow's been working away on that little blue plastic thing there for quite a long time. While I've been getting ready to get back to work on this radio here. This guy's been out of my shop now for a couple of weeks while I work on other radios, but he's back now. I think I've reminded myself where I am with this radio too. I think I'm finished with the AM radio band, at least the initial alignment and the like, and I'm about to do the alignment on the two shortwave bands, the so-called police band, amateur and aviation, police, and police. Well, no. I don't think you find any police on this band, but this is a band that's worth aligning anyway. Up in this area, up in the top part between 4 megahertz and 5 megahertz, there are some interesting shortwave stations that can be picked up when conditions are just right. In fact, I listen to African stations in this area of the band. So, but below there, from say 4 megahertz down, it's pretty much nothing but a noise fest. But nevertheless, we should align that. And of course, then it has a second shortwave band, and that's down here. And this is I guess it's probably starting from the end of this band, right around 5, and going all the way up. It's very hard to read this red paint. 18, 9, up around 20, megahertz. Good. Okay. So I guess the first stage is plug this guy in, turn him on, see if it's still working after sitting on my bench for so long, and switch it up on the shortwave band. I have temporary access to an outdoor antenna here, so we can give that a try and just hook up an antenna and see what it does. And from there we can make some decisions on what to do. But I'm pretty sure alignment is the next thing. So let's plug them in and get them going here. Okay. Now, is there anything else we need to take care of before I blow the top? I'm trying to remind myself what is volume and what is tone. I don't remember. This is the band switch here. This is the something. This is probably tone. This is probably volume here. This is of course tuning fast and slow. Wow, it's really stiff. Hey, nothing's turning. What's this? Is this not something I realized before? Ah, this guy's a monster for tuning. What's going on? Okay, here's another problem. It's funny, I don't recall ever. Man. Just tighten right up. Okay, so I got to deal with getting this tuning knob working properly. I don't recall that being a problem. Okay, so no power on yet. Let's flip this up on the side. Okay. Yes. Now that I look under here, I do recall a few things, but I don't recall this tuning thing being. Now it's turning fine. Okay, so that suggests to me that I had this sitting right on here, and I did. You know what? I had this sitting flat. It's actually riding right on here. Just jamming this, but you know, I could loosen this up now. does. Just put a little bit of WD-40 in there. See, the WD-40 is showing up on the other side of the sleeve here. So it's gone right through. Still feels pretty tight. Usually when you hit the mark, there's a big release, you know, things become really loose. So it could be something going on in this arrangement here, but you know, I don't want to be sticking, I don't think I should stick grease in here or oil. Somewhere there's some kind of mechanism between this fine-tuning knob and the coarse tuning knob, and whatever it was slipping. When this thing was pinned, when this was pinned, this was still turning, it was slipping. That suggests to me it's just a friction surface inside here. Probably a spring-loaded friction surface, and if I throw WD-40 in here, it'll be a frictionless surface. In fact, you know what, it's loosened up a lot already, actually. Let's leave it like that. That's really pretty good. Got some grindy sounds coming out of it. Okay, so I'll just be more careful about how I put this down. Then I can make another correction here, and that is put the speaker right up on the turntable. So if you recall, the original speaker is shot, so I have an alternative speaker just hooked up to the voice coil, and I'm pretty sure there's a field coil in this transformer, or this speaker. It still operates. That's why I still have the big plug in there. Okay, no antenna connected, and again, I think the volume's down. This time I can tune the radio. As grindy as it sounds. Oh, it's slipping. Slipped there a bit. Okay, I don't like that kind of stuff. That's pretty good. Can lubricate the actual capacitor. Oh, see, it's slipping there. Sticking, I guess, is the right word. Sticking or slipping, whichever one you like. It's both. It's doing both. It's sticking and it's slipping. Okay, it's good enough though for testing. There's no doubt about that. Okay, can't delay turning it on any longer. Where's the on-off switch? Something funny about the on-off switch on this radio. I think this is the on-off switch, I think, if I remember right now. Okay, we'll see. Is it on? Yes, it is. Oh, that's a little surprising. Heard that before come out of this radio, I'm pretty sure. Scary sound. I wonder what that is. That noise that's coming out of there, that's not from me doing anything. It's something in this radio is not so healthy. Yeah, I don't know. Okay. Still got it running on low supply voltage also. AM radio band. I can't remember now where this goes for AM radio. Is it over this way? No antenna. No sound. Okay, we'll stick an antenna on it. Did I say something about I actually have access to an outside antenna here? So this wire is actually going to an outdoor antenna, or not quite. I can't be sure until I have a radio working here. Not a sound. Pretty sure I had this radio operating, didn't I? Okay, probably on the wrong band. Let's do a little finger testing here. Inject some signals into some of these tubes. In the vast majority of tubes, the cap on the top is a grid cap, and you can touch it with your finger. But in some tubes, actually have a plate cap. Nothing. Nothing. What's happened? Here we go. Hey. Hey, how come? This one should be generating a fair bit of noise out the speaker. What has happened? Here we go again. I have some vague memory now. I mean, if you've been watching this series of videos, like now, and what am I trying to say? I'm trying to say it's been a few weeks and I've kind of lost track of what I'm doing, even though you might have watched the last video before this one just, yesterday or something. It has been 3 weeks of, well, that's really kind of odd. Okay, Jim, so much for what your plans were today. They've all gone south here on this radio. So there's no question the speaker's connected, it's humming. It could be bad tube socket type stuff. Not a sound. This tube's warming up a little bit. Not a single sound coming out of it. Why? Well, maybe it's low supply voltage. Supply voltage right now is 84 volts. See, we got a close look at my meter up here. So my buddy Scott built this meter for me years and years ago. You see, it starts at 100 volts. It doesn't start at 0. So because there's only 80 volts, it looks like it's sitting at 0. So this is a bit misleading to look at from a distance. Well, that's 80. Let's put full voltage on here. Maybe that's the only problem. Because if I turn down the volume, get ready for some action here. You'll see my dim lights will go off. Hum got a little more pronounced. volume back up. Okay, test in. Absolutely nothing. One thing for sure, you don't want to be touching the grid and touching the chassis with your other hand or something like that. You gotta be. What has happened? Okay. Square one troubleshooting here. Power off. That hum is much louder than I would like. Back a little bit. Where'd my little piece of wood go? Now, I did look back at the last video I posted on this radio, and I'm sure the radio was working. Oh, jeez, I almost got my fingers. It was working. Rather fine. Oh, there's still a whole bunch of old capacitors in here. Look at them all. Right. I had something going on with this coil. But it was working. So okay, so that's the cathode resistors. No heat in it at all. It's not particularly good either. Expect a little bit of warmth in there. Why absolutely nothing? This is the radio with the weird extra socket here, and it's like a botched up radio, kind of, I don't know what to say about it. So I guess we'll start with, is the B plus missing in the radio? That's where we got to start. Okay, stick your finger right there, Jim. B plus in the radio. Let me switch it back on, only I'll be on the low supply. Starts humming right away. Almost right away. That sound in the background is my cat still playing. Still chasing stuff. You can hear it anyway. $200 volts. Yeah, we'll leave it at 200. Volts DC, radio's on. So we'll go down near the rectifier tube and the filter capacitors, and we'll look for big voltage there. Wow, that's no big voltage. The other one is right here. Okay, there's definitely not what I expected. Here's some more. Wow, okay, so how come only 15 volts? There should be, I think I put this on the 20 volt scale. 15 volts. That's definitely a problem. Why is there only 15 volts there? What is happening? The first thing I think is something is shorted out and it's pulled the voltage down. If that's the case, whatever it is heating up and it's going to smoke very soon. What else could it be? It could be this big resistor could be open here. Let's go on this side of it. Okay. again. Other side of this resistor. 15 volts. Okay, here's another one here. 15. What about right here? 7. Well, you know, if you can't find a high voltage on these capacitors, I don't think you're going to find it anywhere in the radio. Well, that's implicating the power supply, transformer, the rectifier tube itself, transformer. Well, here's where all the transformer leads come out, this hole here, and the high voltage ones head right for this rectifier tube. Rectifier tube should only have 4 connections, 2 for the heater, and then because it's a full wave rectifier, 2 plate connections. 2 plate connections, pretty sure have these capacitors. So these are the 2 plate connections here. There's one here. So I think I should be able to find the output of the transformer here. That's what I'm aiming for. Should be some huge voltage, like 600 volts or 500 volts or something like that. Hold still, don't fall. So I think it's these 2 here. Wow, 0. Okay, so maybe I got it wrong. Okay, it could be these 2 here. Yeah, you know, I think I got it wrong. These 2 here. Yeah, there you are. 400 volts. 400 volts coming out of the transformer, that's exactly right. But on the other side of the rectifier tube, $15 and the tube is hot. I noticed the tube is hot. Okay, so I think the rectifier tube is shot. How could that be? How could that be? How could that be? How could that happen? How come it's just been sitting here in my shop? Why would it decide to blow, to go? I'm going to touch that guy. It's really hot. Burn your skin off hot. Burn your skin off without saying I'm sorry. Here we go. Come on. Why am I pulling it out for? The only reason is to put it into a tester. Come on, buddy. 5Y4. Okay. This guy over here, I guess a little premature with the antenna going on. So, chance of this tube being defective. It's got a big F written on it. I can think of some letters to follow F that might describe the condition of that tube. Faulty. Failed. Right? Those are the words. Okay, let's bring up a tube tester here. I don't really need to take the lid off, but I am for some reason. Okay. There we are. Now, We're going to do a 5Y4. 5Y4. So look down here. Y4, 5 volts. Just run through these. 5Y4 signal set to, well, a signal doesn't matter because it's a rectifier. No need to set the bias. Doesn't have any effect. Okay, 0030P. 003P 0760. 0760. Isn't that interesting? Already sent. Set. Sensitivity 25. E. Where do we want the plate voltage going? So it says F, P1, and P2. So F, what does F mean? What does F mean? Where'd my little manual go here? Let's see. F. Meter will indicate short when leakage test switch is in position number 1. Okay, let's pop this tube in. Okay. Everything's set okay otherwise. I should plug in the tube tester. Okay, so who wants to lay odds on this tube being defective? I have my doubts. But that's the problem. Simply because what are the chances it just goes defective here? We're all set. Once again, 5 volts. There we go. Pilot light came on. Give this guy a moment too. He's got his own tube inside here, I'm pretty sure. Okay, line check for the aficionados of tube testing out there. It's right on. So the test is performed P1 and P2. So P1 and then we flip it P2. Rectifiers and diodes are tested here. Rectifiers OK is above where my finger is. So this is in the rectifiers OK. P2. Rectifiers OK. So that's you know, it's always better when you find a bad tube because you found the problem. Well. Well. Yes, the tube is well. That is the problem. No reason to think that this tube is causing any problems in here. So what does that F mean? It means fine. The tube is fine. That's what that must mean. It probably means it was tested by Fred. That's probably what it means. So 0 output, 0 B plus. Actually, 0 output is a secondary factor. 0 B plus. One thing I can do here is I can power up the DC side. I'm quiet here because this is behaving as if the field coil's not. No, that's not true. I was going to say it's behaving as if the field coil's not plugged in. field coil plug is way back here, but the rectifier is way down here. Must be some long distance wires traveling up here. No B plus rate on the tube. Am I doing something stupid reading it to the chassis? Would that be the case? Am I looking at the right schematic here? Any chance? Yeah, this is the one that on the back says it's a battery radio. Battery operated receiver, yet there's no way to run it from batteries. So this doesn't show the power supply. It shows a type of power supply, but that's not what's in this radio. Okay, that's not going to help. It's got to be a simple problem to sort out. Just for interest's sake and a sudden aside from the problem I'm looking at, it's got a little tiny battery, carbon button battery in here, and I just wonder if it's still, I gave a little charge up of water to make it activate, but I don't think it's going to last long, so it's been let's see if there's anything left in it. 200 millivolt scale. What's happening there? I'm sure you can hear that too, I have this way of finding weird stuff. So that sound is coming out of the speaker. There's only one lead. The radio's switched off. That's coming out of my meter. How does that happen? It's even weirder. Okay, so one lead laying in the open. The other lead basically touching the grid of a tube in a radio that's not operating. Okay. Interesting things happen all the time in my shop here. Interesting things I cannot account for. I should probably be ignoring. Okay, let's go back to trying to read the voltage on this little battery here. You see, that's an aside that led to a distraction. You know where I'm heading. I don't. Somebody tell me. Where am I heading with all this? Zero. It's like no voltage supplied by the little battery anymore. It's just simply dried out again. Okay, well that's not going to be causing the problem that we've got here at all. I better bring back that. In fact, I'm going to switch to a more pleasant meter to use, which is this one over here. We're going to repeat this test in case pulling out that tube and putting it back in was the solution. Okay, Switch on again. Hum came in fairly quick. What's that tell you? Tells me something's going through the field coil. I think that's what that tells me. That okay, so we're watching this meter here. .50-volt scale. Zero's way off. Okay, 50-volt scale. So that's reading 25 on this meter. .50-volt scale. It's reading, you know, it's reading almost exactly the same as the other meter, 17.5 or so. Be a high DC voltage somewhere down here. This is going to whack my meter right over if I find it. Okay, we'll put on 150. Wow, you pull a whole power supply down from hundreds of volts down to 15. What can do that? Whatever it is, could be a big, very close to a short circuit right behind this. The way I position this, it's twisted a bit. I have to twist it back, but not while things are operating. There doesn't seem to be anything getting hot. Those two things don't go together. You can't have a good rectifier tube, a high voltage output from the transformer, and not find high B plus unless something is pulling it down like crazy. And that thing, I'm sure, would smoke pretty darn quick. No heat in the cold as can be. What are the chances that this connector hasn't made a connection? No, the speaker's humming. The only way it's humming is that it's got current going through the field coil. If I disconnect the voice coil, that doesn't make sense. Which speaker are we listening to? Are we listening to this one or this one? That's an interesting question. Don't know why, but what makes it so interesting, Jim? I don't know. So the hum is coming from the voice coil one. I better put this back up here. I'm waiting for something to, produce smoke. And give me a better hint as to what it is. No B plus, eh? Okay, so that's the cathode there. It's a little, getting my arm in the way, no? A little tiny voltage there. Here. So now my arm is in the way. It went up to like the 15-volt mark. So the whole B plus thing is running at 15. Okay, let's shut off the radio. What I'm going to do, because I'm just worried that I'm stressing out the power transformer or something like that here, while I'm, or even just the rectifier tube itself. maybe it's totally stressed out. I can fire this guy up by using a shop sour, a shop power supply up here. We can introduce a controlled B plus with that. Just give me a second here. Just hunting down some test leads. For it. Okay, so we want to build up the power supply without what? Let me hook this right onto these capacitors here. First I'll move that. Oh, it's not quite as bad as I thought. Make sure there isn't a short. Side of this just goes to the chassis. Now I'm going to want to read these voltages here. My supply has voltmeters on it, but they're not very precise. Like that. Better way. I could have done this a better way, but that's okay. Okay, so that hooks up the meter. Whoops, that hooks up the meter here. Just basically reading the supply voltage. What we're really interested in is the current flow that's going to show up on this meter here. Normally in this kind of arrangement is almost no current flow. The set is off, so the tubes cannot even conduct. So this should really be no current drawn from this power supply under these conditions. Still got the speaker plugged in. I think we're good to go. Okay, so first of all, stand by to warm it up. In the meantime, let me get a better camera arrangement here. Somewhat better. Just bear with me a moment. As usual, I've come in the shop with a certain plan in mind. I've ended up way off in the boonies here, doing a bunch of unexpected stuff. Okay, I think we're ready. So here's another camera view now. You can see this current meter. This is what we want to watch very carefully. You can see the red line up here. That big red line's there for a reason. Much in the camera here as possible. Yeah, you can still see this voltmeter. When I reach across to operate the equipment, I may very well block the camera view, but I just can't be looking everywhere at once. So I think we're all set here. In fact, since it's really all about what goes on with this meter, we'll do this with the other camera operating. Okay, this is down, on. This is already upscale, and I've got no voltage supply here. So I think I'm seeing a short already. Let's go up a bit. Oh yeah. Yeah, that's really very unusual. And I gotta be careful I don't shout into my microphone here. You see the voltage here isn't going up at all. On the other meter, let's see. So that's 15 volts, 25 milliamps. It's only 15 volts though. I mean, it's supposed to be hundreds of volts. So there is a short in this radio somewhere now. I think that's what you got to conclude. There is a short. Well, you know, crazy enough, let's pull out the rectifier tube and we'll see what happens to this short. Now, what could happen when I do this? I've got the power supply set on it's the lowest setting, so in fact it won't jump up or do anything. So I'm watching you can watch it too, I'm watching the current meter while I pull this thing out. It didn't make any difference. Now, it doesn't make a lot of sense to pull more tubes out, but what does make some sense is pulling out the speaker. The speaker has a coil that's right in the power supply, so this might do something. Let's see. It's so unnerving, man. I keep getting sounds out of the speakers while I'm doing stuff when I don't expect it. Oh, you know what? Hold the fort. I've got this power supply run. Hey, this has dropped to 0. Hey. Hey, was that it already? You know what? I think I'm looking right at it. I think I'm looking right at the short. I think I am looking at it. Let's grab that other camera here. We'll see. Let me change the focus and get up really close on this so we get a good look at things. Just 1 second. Okay, here we go. Right there. That's got to be it. I see I started pulling on this plug, and as soon as I did, I started interrupting this short circuit here. And you know, I probably introduced that poking around, moving stuff. I'll bet you that's the whole thing right there. Okay, so let's separate those. Two guys apart. Still have the power supply operating, so I'm going to put it on standby before something funny happens. I'm going to pop this open. Is that it? Was that the whole problem? Well, now, oh, it was. You know how I know already? Quick, take a look at that meter here. Quickly. Okay, so here's the current meter. Current meter is currently at 0. Here's the voltmeter. It's already up a bit. 50 volts almost. So I'm pretty sure I have found the problem. I've made it back to square one here. Oh my gosh. I think I had that big flash on that. Well, again, it's the current meter we want to watch. Now everything's connected. The voltmeter that I have on my bench is reading about 8 volts there. Okay, now we're going to try to turn up the voltage, and hopefully this will not go up this time. Here we go. Let's put it on. Okay, ignore everything I just finished saying because this thing wasn't even on. Here we go. Yeah, everything I said was bogus. All bogus. Except voltage going up, current going nowhere. So that was the problem. Okay, everybody, put your money down. Now I'm going to put down lots of money here. In fact, get some coins out on this one. Okay, so this is a Canadian $1 coin, commonly known as a loonie here in Canada. Because on the picture, because on it, can you see it? Is a picture of a loon. Kind of see it there. A little hard to see, isn't it? Picture of a loon. A loon is a wonderful bird. If you don't know about them, if you don't know about what a loon sounds like, go on the internet and type in what does a loon sound like. A bird, the loon, and it's beautiful. Anyway, good enough. So what do we got going now? We got this power supply on here. We need to disconnect. We don't want to turn the set on with this there. We got a rectifier tube who I have unfairly doubted a couple of times this morning. I'm sorry, tube. Suspicions were aroused, though. I had to do the investigation before I could clear you. Okay, we still have the voltmeter hooked up over here. It's set to 150. Just maybe a touch low. That's okay. We're going to start it on restricted supply voltage. Anyway, so B plus shouldn't come up to full range. Are we ready? Yeah, I think so. Maybe this time the radio will actually work. Okay. Volume. Volume there. Yeah, this is definitely the volume control because of the heavy shielding. I remember now all through here. Yes, it's all coming back to me. There we go. See that? Go right over. So that's now the actual supply voltage of the B plus. It's going down because the tubes are drawing some current. Pulls down the supply voltage. Should be hearing something. I notice the hum is gone. Okay, there is something there. It's just really hard to hear. Antenna? Not helping much. Real antenna? So I don't know yet if the other end of this wire is actually meeting up with a outdoor antenna. I've got 4 wires to connect to. One of which, or 2 of which, go outdoors. So I'll have to sort that out once we get the radio going. It's there. The only problem is you can't hear it. Okay, so I'm going to disconnect the high voltage meter here. Get the high voltage out of there. Rotate back very carefully because I have it tipped up on its side. What band are we on? I don't know. Turn it down. AM band, I think. Turn it up. Even less. Turn it down. That sounds better. There we go. Doesn't seem to help much, does it? You know what? Maybe I've got it connected to the wrong terminal on the back of the radio. Let me try that. Oh, that would be it. So I had the antenna on the ground connection. Hey, I had a 50-50 chance there. Now we're cooking. Hot diggity dog. Okay, let's use this now to figure out, am I on the outdoor antenna? I gotta go in the laundry room here and fool around. I gotta hear this from the laundry room. Well, let's see if I can do it like that. Can't really tell, but something's going on. I think I'm on the outdoor antenna now. Let's see if we can tune something in here. Okay, that's definitely an outdoor antenna now. I think it's a sports talk. It's probably 590, and on the dial here, it's basically, it's just there, 590 right on if I just push this a little bit. Okay, good. Now, we'll try the shortwave band. We're going to guess this is the police band now. Shouldn't expect to hear anything but noise. Fainter and fainter. Yeah, it's some kind of like a teletype signal, which is really hard to distinguish on a radio like this. You need something called a beat frequency oscillator to really hear it. So it's actually picking stuff up around 5, a little over 5 megahertz. Okay, we'll try the next band. Turn this way down. This is the one that's more interesting anyway. This will be the 5 to 20 band. We might pick some stuff up on here. Then again, I might hear nothing. So we're way up on the high end of the band now. Yeah, wow. There's nothing. Nada. There's a little bit there now. It's very, very hard to hear. Some noise. Sounds Italian. Spanish. Spanish. South America, Cuba, perhaps the United States in Spanish. That's at full volume too. So we might be able to align this back into better performance here. It's so weak on the high frequencies. Okay. Various reasons for that. High frequencies just harder to go through the radio. Harder, like for instance, weak capacitors, more susceptible to problems at high frequency, and also I forgot the also. Good enough. Thinking about too many things. I'm thinking about one thing and talking about something else. That's a bad move, Jim. So I think we reached the end of the road here for today. Hey, I fixed the radio. That's a pretty good day. So I think probably, considering how weak it is on high frequencies, there might be one or two choice capacitors in here that really need to be changed out. I'm not so sure. Like, I don't think, this is the tone capacitor. What does he matter? I don't think it matters much. This guy, I'm not sure what he's doing. We've already solved the problems with the cathode resistor. Sorry there. I gotta go drink some more coffee. But I think that's good for now. We're all ready. We're ready to start. Hey, see you on the next video.